So irrational numbers are those rational numbers which can be written in the form of root 2, root 3, root 4, root 5, like this, means which are not perfect squares. Their roots are always non-terminating, non-repeating decimals. And pi, just remember, is an irrational number because it is non-terminating, non-repeating decimal. And now we find two rational numbers between two irrational numbers. Rational, we have seen irrational numbers, two irrational numbers between 1.1 and 1.4. So how we will find? We will write the number, one number between 1.1 and 1.4 after one decimal place or after two decimal place, but the number should be in between 1.1 and 1.4. So I have taken 1.2, then put 10, then 2, then 20, then 2, then 30. So every time you have to increase the number of zeros. Okay. And similarly here, 3 and 10, then 3, then 20, then 3, then 30, like this. So these are the two irrational numbers between 1.1 and these are irrational. These are irrational numbers between 1.1 and 1.4. So this is the extra knowledge about finding the irrational numbers between any two rational numbers. Irrational numbers between any two rational numbers. Now we can have some questions from our textbook. So we are starting now exercise 1.1. State whether the following statements are true or false. Justify your answer. Every irrational number is a real number. Irrational number. Yes, this is very important. This is true. This is true. And you must be thinking that we cannot express root 2 on the number line. We can. We will do. That is in our course. The next question, last question of this exercise is to find the point to represent under root 2. Under root 2 can be expressed on the number line. Just keep in your mind all irrational numbers can be represented on the number line. Okay, and how to represent that we will do. Can be represented on the number line. So it is true statement. Okay, because all rational and irrational numbers together form a group of real numbers. The justification is what? Because you can write the answer as because all, as I told you in the starting, if you see the first lecture there, I told you about the real numbers. So all rational numbers and all irrational numbers. All rational numbers and all irrational numbers form the group of real numbers. So that means, as I told you, that real numbers are divided into two parts, irrational and irrational numbers. Rational and irrational numbers. So that's why it can be expressed. Okay. Second, every point on the number line is of the form where m is in the root. This is false because every point is not under root m. under root 2, but if you see point number 1 or 1.1 on the number line, it is not root of something. So this statement is false. Every point is not like under root m on the number line, because no negative number can be square root of any natural number. Negative number, if we go to the negative side, 0 and then -1, the negative number cannot be the square root of any natural number. Any natural number, root of any natural number cannot be negative number. Okay, so it falls because of the reason you will write, because no, try to understand each and everything. No negative number can be the square root of, because the question is what is square root. They ask that square root of every number, every point is represented by the square root of some number on the number line. So that's why we are taking square root of any natural number. Cannot be this negative number cannot be the square root of any natural number, of any natural number. So negative square root, we cannot get the square root of any number cannot be negative. Got it? Square root is always. So now third one, we have the third property. Is third question, every real number is an irrational number. This is also not true, because every real number is not an irrational number. Some are rational, some are irrational numbers. So this statement is also false. Why? Because rational numbers are also a part of real numbers. Reason is because rational rational numbers are also a part of real numbers. Real numbers. Got it? Question number 2, exercise 1.2. Are the square roots of all the positive integers? What are positive integers? +1, +2, +3, +4, and so on. All are positive integers. They are asking, are the square root of all positive integers are irrational? No. If we put the square root of 1, irrational, 2, irrational, 3, irrational, 4, rational. 4 is rational. 4 is rational. So this is rational. So we can write no, can write in short no, or we can write no. The square root of all positive square roots of all positive integers are not irrational only. But the reason is, if we take a positive integer, we can write like this, positive. If we take positive integer, say that I have taken say 4, then its square root, then its square root is 2, which is a rational number. That is the reason, which is a rational number. So when the reason is asked, you have to write the reason. Otherwise, you can write no only.